The OSI 7-layer model is a theoretical framework that describes how data communication is achieved over networks. The OSI model breaks down the communication between two devices on networks into 7 separate layers. Why use the OSI 7-layer model? The OSI model provides an easy to understand structure that enables the network to be visualized, which aids heavily in finding weak points and diagnosing issues within the network. When transferring data from one device to another, it travels up or down the OSI layers. When receiving the data, it travels up the OSI layers, and then when sending the data, it travels down the layers. An easy way to conceptualize the 7 layers is like 7 machines in a production line. The OSI model consists of 7 layers. Starting from the bottom of the model, there is the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The 7 layers are separated into 3 main categories, being the software layers, the heart layer, and the hardware layers. Starting with the uppermost layer is the application layer. The application layer is the closest to the user's input. This layer takes data input from the user and attaches a given protocol to the data when the user is sending the packet. When the user is receiving the data packet, this layer removes the protocol attached to the data and hands the data to whichever application is in use. The presentation layer is the next layer. This layer can be thought of as a translator. It specifically deals with data preparation, such as encryption, decryption, and compression. This layer makes it so that the data can be used by the next layer. The final layer of the software layer is the session layer. The session layer is responsible for establishing and maintaining a connection between two devices. This layer reads or adds information about how long the connection has been open and for how much longer it needs to be open for. The transport layer, renowned as the heart of the OSI model, is responsible for using data transmission protocols such as TCP or UDP. This layer also acts to split and build data, depending on the direction the data is traveling. It breaks apart data before it reaches the hardware section and will reconstruct the data before it reaches the session layer. This layer has the capability to handle flow control and error control. The first of the hardware layers is the network layer. The network layer is somewhat of a navigator. This layer tells the packet how to get to its destination. It assigns a route for it to travel. It also breaks apart and reconstructs the data much like the layer above. However, this layer is not always used. Specifically, it is only used when the data is traveling outside of the network. The data link layer defines what the format for the data will be when it's transferred. It has a similar navigation element to the prior layer. However, this layer does not route over to another network. It uses the physical address of a device within the network to direct the packets to the correct device. This layer will have flow control and error control. One of its primary purposes is correcting any errors that occurred in the physical layer. The lowest level layer is the physical layer. The physical layer transmits the data from the layers above as a raw bit stream over a medium. Bit stream is represented as some kind of electrical signal. This is the layer at which data is actually sent from one place to another. An alternative to the OSI 7-layer model is the TCP/IP model, which is much better used as a practical approach to a network model, rather than the OSI model, which is much more theoretical. This makes the OSI model a preferred option for teaching, and the TCP/IP preferred for real-world use. To conclude, the OSI 7-layer model is an abstracted model of how data moves around networks. It is comprised of 7 distinct layers providing clear lines between the different parts of data transfer. Primary use of this model lies within theoretical application of networking.